Okay, the last reaction to know in the organic chemistry chapter is the esterification reaction, which is a condensation reaction. So a condensation reaction is very important in biology and in biochemistry. It's the bonding together of two molecules and in the process producing a water molecule. So esterification is really sort of like a subset of the condensation reaction that specifically produces an ester as well as that byproduct of water. Esters tend to have very nice smells and are often used as artificial flavors and scents. So the overall reaction is that a carboxylic acid and an alcohol are going to react together, and the products are going to be the ester and water. So what happens is, where does that water come from? Well, it comes from this OH and this H from the alcohol. And so those two things together, as they pull together, they're going to produce that water molecule. And in the process, this C to O and this C to O single end up forming this group here, which is the ester functional group, COOC. You can see that the carboxylic acid, in this version I've drawn the 4-carbon, right, thing right here. That is really like the parent group of this ester. Okay, and then the alcohol, which is this part, ends up being considered more of a side chain or an attachment for that ester. Okay, so when you name this, this carboxylic acid is called butanoic acid, and this alcohol is ethanol. So when you name the ester, it becomes ethyl, as like a little attachment prefix to the name, ethyl butanoate. So the carboxylic acid is really the parent name of it, the butanoate. And the ethanol just becomes an ethyl group in the front. So ethyl butanoate is the name of this ester. The other details, concentrated sulfuric acid acts as a catalyst. So that's the condition to know. And a couple important factors about how you would actually carry this out in practice. Well, really important note is that the ester cannot hydrogen bond with its neighbors. It doesn't have H enough. It's COOC. It's a polar molecule. It's a little bit polar. Not nearly as polar as the carboxylic acid in the alcohol or the water, all of which have the capability to form hydrogen bonds. So as the ester gets formed, one, it could be separated off by distillation in a similar way that an aldehyde could be separated from alcohols because it has a lower boiling point. So you could separate esters out of these mixtures through distillation. Esters often naturally separate out into an insoluble layer because the carboxylic acid, alcohol, and water, because of that hydrogen bonding, are much more likely to all mix together. And the ester, being much less polar, often forms an organic layer on top of those other things. And so you can just take the ester right off of the top as it forms. So that's all there is to the esterification reaction, knowing that you produce water and this ester from the alcohol and carboxylic acid, being able to come up with formulas and names. The condition is concentrated sulfuric acid. And some important notes about the IMFs are that the esters do not have the capability of hydrogen bonding, and therefore they may separate naturally into an insoluble layer, or they can be easily separated with distillation.